In this video, you'll find a solution to the June 16, 2020 exam PA. Notice that there are many possible solutions to these exams, and no single answer will be the best. This solution is intended to save you as much time as possible, while reducing your probability of making a mistake. To begin, you'll have the project statement. You'll also have the Word template and the RStudio template. When you work on these practice exams, it's a good idea to start a timer. Set it at 5 hours and 15 minutes, and this will let you keep track of how much time you spend on each question. The first thing that I will do is to read through the project statement. I will skip over the general information for candidates because this has been the same on all of the exams. The business problem. Your actuarial consulting firm has been hired by the large healthcare system merged and acquired clinics and hospitals, MAC, to help the hospital executives gain a better understanding of the factors that drive inpatient length of stay. This insight will allow the administrators to better understand and manage their patients. So the key point here is that they're looking for insights rather than a powerful predictive model. So when you think about the model decisions or variable transformations, keep in mind that you'll have to be able to explain everything that you do at the end. Mock has provided data on historical inpatient encounters for patients with diabetes. Each encounter includes the length of stay in hospital measured in days. Your task is to use the available data to identify and interpret the factors that relate to inpatient stay duration. To help you get started, your assistant has done some preliminary analysis, which are scattered throughout the supplied R&B file. The data dictionary at the end of this document describes the available variables. Let's take a look at the data dictionary. First of all, there's a lot of variables here. There's a mixture of categorical and numeric values, and I see that the data is on the patient level, so each observation is one patient's stay. Here's the target variable, the number of days. Next, I would like to read through the tasks to get an idea as to what topics will be on the exam. I see the first question, 8 points, edit the data for missing or invalid data. 15 points, explore the data. 4 points, consider 2 data issues. 6 points, write a data summary for your actuarial manager. So I could see right away that there is 8 plus 15, 23 plus 4, 27 plus 6, 33 points just on the data itself. So I really want to be careful here. Next, perform principal component analysis. 8 points. 10 points, construct a decision tree. 7 points, construct a GLM. 4 points, perform feature selection and lasso regression. 7 points, discuss the bias variance trade-off. 4 points, consider the final model. 7 points, interpret the model for the client, and 20 points, write an executive summary. So it looks like this is going to be a data-centric exam. Oh, this is interesting. The following task uses the Pearson goodness of fit statistic to evaluate the models you create. This calculation is provided in the code. So this is going to be the evaluation metric here, and this looks relatively new to me. So it's quite common that they will include new topics or topics that are barely covered on the syllabus in order to keep you on your edge. So don't be surprised if you see things that are new. So then I'll just immediately start on task 1. Edit the data for missing and invalid data. So there in the R&D file, there's a lot of commentary, and there are also comments that tell you what to do. In some cases, I will use my own code. In other cases, I'll use the provided template code. Use your own best judgment. If you can do something faster on your own, then by all means do it. But if you practice by using the SOA template code, then it's best to stay with what you know well. So this is loading plier and dplier. So I'll just run this chunk and I look at a summary of the data. So I can see the days is numeric and gender. I see this is categorical, but this is just saying character. Age is also a character. Race is also a character. And this doesn't give me useful information. So one way to fix this is to go to data.all and then mutate if is character as factor and then run a summary. And this gives me the counts. It says there are 5,338 females and 4,659 males and so forth. Just saves me time. Okay, so first of all, change numeric variable types to factor. When you saw here, so numeric data types to factor data types. So here's the code that they give to us. So I need to change days is still going to be an integer because it's counting the number of days. Gender will be a factor. Age will have to be a factor. Race weight. What is weight? It looks like these are all question marks. I see weight is a range here. Admit type ID. This is identifier corresponding to the type of hospital admission. Emergency, urgent, elective, or not available. This should be a factor. And the way to quickly highlight this variable is just to double click. Left click twice and you'll select this whole text and then press Control C and then press Control V to paste. And then there's number of procs, which should be an integer. Number of meds, that should be also. Number of inpatient, number of diags. These are fine because these are all numbers, so they can stay as integers. So I'll just convert age and admit type to factor. I'll have to comment this template out. I want the R&B file to be able to run from start to finish. Okay, what's the next part? Remove variables or columns. So this question is edit the data for missing or invalid data. So where's the invalid or missing data? Look again at the summary. I see that race has this question mark. Weight also has this question mark for missing values. And that's it, right? So it looks like the variables are going to be weight. Let's just go back to the template and first document what we've done. So I converted age to a factor. Actually, the age should not be a factor. Age should be, well, yes, because age is a bin, so it should be a factor. Age to a factor because there are only discrete values. I also converted admit type ID because it represents the type of admission. I made changes to each variable to fix the missing values. First of all, I looked at your gender. There were 3 missing values. So when I encounter missing values, there are several ways that I could deal with them. The simplest is just that I could remove them. In this case, there's only 3 observations that are missing. I just removed these because there are not enough values to make a difference. Then I look at age. Age doesn't have any missing values. It just has the other category. Race has 226 missing values. That's a fair amount. Judging that there are only 10,000 observations, 226 fairly high number. So what I would do is I would just put this missing data into the other bucket. There were 226 missing values, which I grouped into the other category. So how would you do that? Let's look at the code that they give to us. And they say re-level factor variables, explore the data. Here it is. Replace variable with the variable name values to be removed. So this is calling the subset function. So it's removing variables which have a specific value. And this is dropping the levels. First of all, I have to fix gender. So I'll make a new data frame. I'll call df equal to data.all. Do I want to do that? No, I'll keep using data.all. Data.all and then filter age, gender does not equal, and now I need this value, invalid or unknown. And in base R, you would do data.all equals data.all, and then take a subset of the rows. So then you do values where data.all $gender is equal to gender. So you could do this in 2 steps. First of all, you have to find the rows that you want to remove. So you look at data.all gender is equal to unknown right here. This will give you Boolean true false values. So I'll name this something like, gender missing, right? It's equal to this. And then I just say data.all and then minus gender missing, like that. Personally, I think that the dplyr filter method is a little bit faster. So race has 226 missing values. So data.all is equal to data.all, and then I'll mutate race is equal to, if else, race is equal to question mark, then yes, I would say other with an uppercase O, and no, I'll just keep it as race. And if you wanted to do this with base R, you would do data.all. First, you have to find the variables, find the records which are missing. So you'd say race missing is equal to data.all, race is equal to question mark, right? And then you say data.all. Now you have to select race, right? Because this is the column that you want to update, is equal to data.all race. Well, so then you could also use an if else. So I would also use data.all race is equal to question mark. Yes, I would use other. I would use data.all race. I don't need this part here. Both do the same thing. And just to check, you can also then rerun the summary here. And something's wrong. I'm getting a lot of NA values. Okay, so I'll rerun this to get back to my initial data. First, let's just rerun the age part. Make sure age is okay. And then admit type ID. And then remove the unknown or invalid gender. So I'm going to say data.all equal to data.all and then filter. And if I do this and then look at gender, oh, I still see that I have some values here. So I probably didn't type this correctly. Let's try this again. it's still saying it's not working. Let's try the following. Let's try data.all filter gender is equal to this. 0 rows. Why is that not working? Well, what is the class? Class data.all. So in other words, I might have the wrong data type. Gender is a character. Oh, let's try something else. Let's just saying filter gender is equal to male and see if this works. Yes, this works. So there's something not right. The quick fix around this is just to say gender is in either male or female, or it's excluded. So if I do this, this should remove the missing values. And there it is. Now the gender is just male or female. I'll look at race. So I'm going to comment out these lines because I've already made this fix. I'm just including it for illustration. So now race is good. There are more values in this other category. And then I'll comment out this. And then moving on to admit type ID. I just want to make sure that these values make sense. 1 to 4. So it's emergency, urgent, elective, not available. Looks good. Weight has 9,688 missing values. So I will just remove this. So there were 9,600 missing values out of only 10,000 records overall. And so I just removed this variable. So the way to do that is just to say variable is equal to null. So data.all weight is equal to null, or if you like to use dplyr, you can say data.all and select minus weight. And I have to say data.all is equal to data.all and then select minus weight. Next up is admit type ID, which is fine. Then metformin, which is fine. Insulin, which is fine. Readmitted, that's okay. Naprox, meds, num inpatient, num diags. These are all okay. Let's go back to the project statement to make sure that I got full question. Combine or reassign variable levels to address missing or invalid values. Reduce levels. So I did this to address the missing variables. What about reducing the levels? So if there's certain variables which have only a few values and certain levels, those should not be used in the model because they don't have enough credibility. So if I look at the weight variable, I can see that there's only 9 records that are in 125 to 150. And similarly, there are only 10 that are in other. So what I might do is just combine these 3 together. So I would also say, but this actually doesn't matter. This is irrelevant, remember, because we deleted weight entirely. So looking at these other values, it looks like they're okay. I see that there are only 63 cases where race is Asian. Also, because there are only 63 values, it could be reasonable to combine that into other, just because there's not enough credibility in the data to make good conclusions based on that. So if I say data.all race is equal to if else data.all race is equal to Asian, yes is equal to other, no is equal to data.all race. And again, in dplyr syntax, it's just like we did. So you could actually make this, if you want to do this all at once, you can just say if race is question mark or equal Asian. But in any case, let's just keep what we have and then move on. There were also only a few records which had certain levels for race is equal to Asian. And so I combine these with the other category so that there is more credibility. Finally, it says to provide rationale for your decisions and make the corresponding changes to the data frame. So I know we've already gone through and said what we did, but that's not enough. We also need to write out some explanations for each. And I know this is a lot of extra work, but it's what the question's asking for. So for gender, we said that there were just not enough values to make a difference. For race, we said we group these into the categories, but we also need to say that there could be a pattern in why these values are missing, which would cause these results to be biased or prejudiced. For instance, when the data was collected, there could be more missing values for certain races than for others due to the surveys which ask patients of their race. Or for weight, we saw that there are a lot of missing values here. Because there are so many missing values, it doesn't matter why this variable is missing, because there are simply not enough records to use. There were also a number of cases in the admit type ID which had a value of 4 for not available. So you might be wondering, should these be included or should they be removed? Well, first of all, consider the number of cases. You can see that there are, in fact, 1,021 records. The other values are for emergency, urgent, elective, or not available. So consider the business problem. If someone goes to the hospital for diabetes, why would their admission type be not available? Could it be that they are rushed into the ER and they don't go through all of the regular paperwork? It's likely that there's some type of pattern in the reason the values are missing for certain patients. So it would be a good idea to include the variable as not available. As a general rule, if there's a pattern in the missing values, it's removing information to delete those records. However, an alternative solution would be to remove them, but just be sure that you justify your reasoning in the document. In our case, I choose to leave them in to see if there is a predictive pattern. So I would just summarize this by saying this variable came as numeric, but is actually a factor. And so I converted this to the factor data type. I also set the base level to the one which had the most observations, which in this case was admit type 1, which was emergency, I noticed that there were 1,021 cases where this was not available. This could either indicate a missing value or it could be intentional. If it is a missing value, then I recommend not removing it because there could be a pattern in the missingness. Some patients who have their values omitted may have done so because of medical reasons. So I chose to include these values and test if they will be predictive. Another type of missingness, which is more subtle, is when values are 0, which should not be 0. Consider the numeric variables: num-prox, num-meds, num-inpatient visits, and num-diagnosis. Does it make sense for these values? For instance, number of procedures goes from 0 to 6. So does it make sense that a patient would have these values? Consider the data dictionary. Num-prox, the number of procedures performed in the 12 months preceding the encounter. You can look at the counts of these values by doing summary, by doing data.all, and then count num-prox. And you see that most patients don't have any procedures. This makes sense. You can also do the same for the other values. Num-meds is the number of medications. So most patients have a high number of medications. Very few patients only have less than 5. Ask yourself, does this make sense? This is the number of distinct medications administered in the past 12 months. Yes, that seems reasonable. What about the number of inpatient visits? Most patients, as you would expect, never go into the hospital. There are some patients who have had 9, which seems rather high. So it may be a good idea to comment on this. IP, I noticed that there were 12 patients who had 9 inpatient visits prior 12 months, which seemed high to me. There were also 15 who had 8 visits. I chose to leave these as they are, but recommend investigating them to be sure that it makes sense to compare them with the other patients in this analysis. And then there's also num-diags. So this goes from 1 to 10. So what's interesting here is that you can see this number is slowly increasing. It's increasing. All right, there are almost 5,000 patients who have 9 diagnoses. And then there are only 2 which have 10, which is surprising. So I would definitely include this info. Could even copy the table. So it was, I'll say, it was surprising to me that there were many patients who had a large number of diagnoses leading up to 9, where there are 4,914, but then only 2 who had 10 diagnoses. So remember, this is the number of diagnoses entered into the system. This is described as the number of diagnoses entered into the system. And so it could be that these 2 records are errors, or that there are more patients who should have 10 diagnoses. I chose to leave these as they are. Task 1 has a number of parts, and it would be very challenging to get all of these exactly as the SOA solution does on the real exam. But don't worry, there are multiple ways of answering these questions. The main question that this task is looking for is to provide clear rationale for your decisions. For instance, the admission type variable could have been missing, or it could have been removed. The number of meds variable could have been considered missing for values of 1, or it could have been removed. The same for the number of procedures. So regardless of what decisions you made, just be sure that you have adequate description. Task 2, explore the data. 15 points. Investigate the distribution of the target variable and 3 variables that are most likely to predict the target, including among these at least 1 specific and 1 categorical variable. Do not discuss the other variables in your response. Let's look at the data dictionary and see what we're trying to predict. We're trying to predict the number of days between admission into and discharge from a hospital.
So what does that mean?
It means that, well, patients get admitted to a hospital because they have some type of underlying condition. And then they go through treatment and they recover and then they leave. So we're given data for historical inpatient encounters for people with diabetes. So without even looking at the box plots, I can make a guess as to which variables I think would be predictive. Let's go back to the question though. So show key descriptive statistics, create visual representations, graphs and charts, explain, if not the target variable, why you selected this variable and how the variable relates to the target, state your observations from the descriptive statistics and visual representations. Limit your comments to 1 page. Statistics and visual representations will not count towards this page limit. So let's look at the code that they've provided. First of all, for these chunks that I don't use, I can either delete them, which is risky because I might end up needing them later, or I can type eval equals false. So this will, when I run the R markdown document, it will just block these. Yeah, so let me just copy eval equals false to these other chunks that I don't use. Oh, and before I forget, I do have to set the variable levels to those which have the most observations. And you can use the SOA's code to do this, but what I like to do is to use this function in dplyr. So you just say data.all is equal to data.all, and then mutate if is factor in frequency. This is in the forcats library. So I just have to load forcats and then run this. And then if I look at the summary, I can look at the base level. So for instance, age, the base level is always the first one that appears. 70 to 80 has the most observations, 2,541. Admit type 1 also has the most observations. And I still see that there are some characters. So what I would also do is just copy this and then mutate if is character, also convert it to factor in frequency. Now if I look, I'll see gender, base level is female, race, base level Caucasian, metformin, base level no, insulin, base level no, etc., etc. And I would just add that comment to the statement here. Lastly, I converted the factors base levels to those which have the most observations. Okay, going back to task 2 though, data exploration. They give us this template code. They show us how to create a bar chart. That's great. And they also say target variable means by predicted values and correlations of the target to the numeric variables. Then they also give us some code that says split histograms in box plots by target and factor variables. It looks like they give us all of the code that we need for this question. We really just have to spend our time thinking. So let's look at the histogram. So the histogram just shows the distribution of the variable. It doesn't tell you anything about the target. So like in this case, this just tells you the number of people that are in each age category. It doesn't tell you how the target value changes. But recall that the question was asking to investigate the distribution of the target variable and 3 values that are most likely to predict the target. So first of all, let's just look at this histogram, hit copy, and then paste. And I'll also look at the summary. Let's just look at a summary of data.all days. So the target variable is the number of days that a patient spends in the hospital after being admitted. This has a mean of 4.4 and a median of 4.0, indicating that it is right skewed, which you can also see from the histogram. Now I want to think of some variables that might be predictive. Gender, I would not expect to be predictive because the person's gender doesn't have a clear impact on how long a person will stay in the hospital. Age, it could be that older people are less healthy and so that they spend longer in the hospital. I could look at the mean number of days by age here. And so this is somewhat confusing because the age here is not ordered. Well, it goes 10, 20, 90, 100, 30, etc., etc. So, but I do see some significant differences, like the mean is 4.7, and then for old people from 70 to 80. For kids from the ages 0 to 10, though, it's much lower. So I would say I expect that the age variable will be predictive of the length of stay. I noticed that older people tend to have longer stays than younger people. Now let's grab this histogram. So most patients are older, over the age of 50. And I can say the median length of stay for people over the age of 50 is between 3 and 4 days, but only for people under the age of 50, 30 to 40, it's 3, 20 to 30, 3, 10 to 20, it's 3, it's between 2 and 3 for patients under 50. I could also look at this histogram. So right now, there's not really a clear way that I could show the relationship between age. And I think including this table would be good though. So this table is not ordered. That's okay. It doesn't have to be. The table above shows that there's a significant difference in the mean length of stay across the age categories. Now, what other variables might be predictive? So we want to look at the mean value to see how much it changes. So like admit type, for instance, it's 4.3 for admit type 1, 4.7 for admit type 2. So that's not a huge difference. Like the median is 4 or 3. Metformin, it's either 4, 4, or 5. That's not very significant. Well, insulin is 3, 4, or 4. So I suppose all of these median values are always, it looks like they always have a difference of 1 or 2. Well, this has a difference of 2. This goes from 3 up to 5. And there's also a nice spread of observations across these values. So I would expect that the number of procedures would also be predictive. So let's go back to the data dictionary to see what that is. This is the number of procedures performed in the preceding 12 months to the encounter, the num-prox. I expect that the number of procedures will also be predictive. This includes only procedures over the preceding 12 months. And so if you just think about it logically, unhealthy patients will need to have more procedures and might be more likely to have a longer recovery time and length of stay. So I would include this table here, and I could say, there's an even spread of observations with most patients having no procedures. Those who don't have the lowest average length of stay of 3.78, whereas those who have 5 have an average of 5.4. This makes sense because patients who have more procedures probably need more time to heal after being admitted. I also want to look at some of these graphs. So where's number of procs? There's number of procs. So now I have 2 of the 3 variables, and I just need 1 more. So I've looked at age, race, insulin, readmitted, or num-procs. Let's look at readmitted. 4.2 for patients who were not readmitted previously. 4.77 for patients who have been readmitted less than 30. What does that mean? If I look at the data dictionary, it indicates whether the patient had been readmitted after an inpatient stay in the 12 months preceding the encounter. So less than 30 means that the patient was admitted less than 30 days. So it means that these patients are less healthy. If they've already had a hospital procedure and had a readmission in the last 30 days, it means that something's wrong and that they're more likely to have further hospital stays. So, say patients who had a history of being readmitted tended to have longer stays. Patients who had not been readmitted at all had the lowest length of stay at 4.2, whereas patients who had been readmitted in the previous 30 days had a mean of 4.77. There were over 1,000 patients in this group. So I know this is not just random chance. So if there were only like 10 values in this bucket, even though this average was higher, it could have just been because of random noise in the data. But because you have a pretty good sample size of 1,102 patients, that means that there's something happening. It's not just random noise. So you could also choose other variables in the model. You don't need to just look at these 3 or the 3 from the SOA solution. The question's really just asking for you to be able to explain your arguments using graphs and summary statistics and words. If you had chosen other variables but provided good explanations, you should get full credit for this question. So I also can look at the correlation. So this looks at like days, number of procs, number of meds, number of diags. So let's look. So here I can see that the number of procedures has a correlation of 19% with days. Well, the number of meds is actually higher. It's 0.47. So this would also be a good variable to look at. So recall that the correlation maps, if a correlation is high and positive, it means that as one variable increases, the other variable tends to increase. And conversely, if the correlation is negative, it means that as one variable increases, the other decreases. But correlation is also only a linear measure. So it could be that a variable is highly predictive, but the correlation is low because it could have like a quadratic relationship or some other nonlinear relationship. You might have heard the expression, correlation does not imply causation before. It's also possible that 2 things could be correlated, but it could be due to some other reason. So you can't just look at correlation to determine predictive power. You also need to include other information in the model. Otherwise, our job here would be done. We wouldn't need to do any further analysis. We could just look at the correlation matrix. So I'm going to just include the correlation here in number of procs, the above. So the correlation between the number of days and length of stay was 19%. This means that the length of stay increases as the number of procedures increases. Let's also look at one of these histograms. So this tells you if the distribution is significantly different for the 2 categories. So we used readmitted. So I would want to change this to readmitted. So the fast way to do that is to just change the values here of gender to readmitted. So I'm just going to select copy and then see, okay, group is equal to gender. Now its group is equal to readmitted. Fill is equal to readmitted, and I still see gender here. Something's not right. There it is. So here I can see that, so on the box plot on the right, you see the median value as the center line, and then this top of the box is the 75th percentile. The bottom of the box is the 25th percentile. So for patients who have been readmitted in the previous 30 days, you can see that they have a higher median length of stay, and that their distribution is also higher because the 25th percentile is higher than the 25th percentile for patients who haven't been readmitted. This histogram shows you a similar picture. Perhaps it's easier if you make this larger. So you see that the blue line, which is always on the right is always higher than this red line, which indicates that patients who were not readmitted tend to have a higher length of stay. Because if the line is further to the right, it means that days is higher. It means that they had a longer stay. And notice that the blue line is always to the right of the orange line, which means that those patients had a longer length of stay. Let's copy this into the document. So I'll just summarize what I said. The graphs below show that patients who were readmitted in the prior 30 days have longer stays. The box plot on the right shows the median days as the center line in each box. The blue box for readmitted less than 30 is highest, and those in the red box, no readmissions, is lowest. The histogram on the left shows that patients who have been readmitted spend more days in the hospital because the blue line is always higher than the orange line. Task 2 asks you to provide a number of visual and statistical explorations. Many candidates failed to adequately explain their reasons for choosing the 3 predictors. In your report, it's important that you include enough words in your document. For instance, when you create a graph, such as a histogram, be sure to actually describe the different points on the graph. Or if you use a box plot, such as below, notice how their commentary describes the box plots below show that the median and third quartile number of days, etc., etc., etc. So just pay attention to the number of words that they use for each graph, as well as the specific descriptive language which they use to highlight the different parts of the graph. The solution in the video probably uses too few words to get full credit. In addition, some of the tables are not as neatly formatted. Now, the SOA's report does say that a component of the grade for the specific tasks is made up by the quality of the exposition. So if you have time, it may be a good idea to first paste these tables into Microsoft Excel and then paste them into RStudio. But if you don't have time, including the tables as they are is probably sufficient. Task 3. Consider 2 data issues. Identify a variable that may have potential ethical concerns. Discuss the considerations related to the using this variable in a model for this business problem. Regardless of any concerns, continue to use this variable in subsequent analysis. So let's look at the data dictionary. The variables that would come out to me would be, as potentially having ethical concerns, would be gender, age, or race. Now, it could be that hospitals are giving people discriminatory care based on one of these. For instance, most hospital workers could be men or women, and so they could have a tendency to treat patients differently depending on their race, just from a social context. It might not have nothing to do with the medical reason. Or age, it could be that patients who are elderly, who do not have a habit of speaking up as often to the nurse, may be getting ignored. They may be in a hospital room not getting care when they should be, simply because they're older and they're not being as vocal. Or race. It could be that the hospital staff are racially discriminating, and that this is causing some patients to have worse care just because of their racial status. The key point in each of these cases would be that certain patients would be getting worse care because of a non-medical reason. The hospitals need to use all of the information available in order to provide the best quality of care that's possible. The most obvious variable, I think, would be race, because it's such a controversial issue. So I'll go over to my project statement and say that the variables, this is only a 4-point task, so I don't want to spend too long on it. So I'm not going to talk about the first age and gender variables. I'll just say the race variable has potential ethical issues because racial discrimination has been a problem in hospitals in the past. Think about the business problem. The client, Mac, is concerned with the quality of care that patients are receiving. Patients should be getting the best care possible to be as healthy as possible. It may be that including the race variable is useful to this end by making us aware of discrimination practices which may be taking place. And so to include this in the model would help to identify these unfair actions. There are other problems too, though. There may be other problems as well, though. For instance, we did not audit the data, and it could be that some races have more missing values than others, or that the values were recorded incorrectly for certain races in an unfair manner. And to include this prejudice variable would introduce prejudice into the model. Part 2. Your assistant informed you that an additional variable that counts the number of laboratory procedures during a hospital stay is available. Explain whether such a variable should be included in your model and justify your position. Well, first of all, it seems like this would be a very useful thing to include. We already have the number of diagnoses, lab visits, and medications that the person is taking. So it seems natural that we would also have the number of lab procedures. However, this question contains a trap, and this is why it's very important to read the questions clearly. Your assistant has informed you that one additional variable that counts the number of laboratory procedures during the hospital stay. Compare this with the definition from these other variables. The number of procs counts the number of procedures performed in the 12 months preceding the encounter. The same for the number of meds in the 12 months prior to the encounter. So the key point is that these variables refer to historical information, whereas this new variable would refer to the current patient's stay. Now, our goal is to try to predict how long the person will stay in the hospital. And so we can't actually use this info, otherwise it would leak the signal into the model. In other words, if a patient had a long stay, they would automatically have more procedures. So if your client wants to use your model in real life, then they would need to have all of the data in advance. However, if someone hasn't yet stayed in the hospital, of course you can't collect information as to how many lab procedures they will have. That's not something that you can get. So in other words, you can't use the number of lab procedures because you will not have that data in time if you're building a model. So let's just write that quickly. So I would say, first of all, the number of lab procedures seems like it would add additional information to the model. However, we wouldn't have this information until after a patient has stayed at the hospital, and so could not use it. If we used the number of labs that were conducted during the current stay, this would leak information from the target variable, the number of days, and would make the results meaningless. Contrast this variable to the number of procs, which records the number of procedures from the past 12 months. If we could get the number of labs which occurred in the past 12 months, then this would be useful. Task 3 expects candidates to demonstrate critical thinking skills. So this is more than just using a canned response or repeating an answer that you've heard from another exam. It's expecting you to show that you've thought through the issue and can weigh the pros and cons of either including or not including the data variables. In the case of race, it's important that you don't just look at the advantages, but also the disadvantages. The same is also true for the number of procedures variable. So for race, it said this could be discriminatory, but it also could be ethical if it leads to improved care for all cases. So there's an advantage and a disadvantage. In our answer, we said it could be that some races have more missing values than others, and so that would be a disadvantage to including it because it could cause bias in the data, and it could be useful perhaps from a medical or genetic standpoint by helping hospitals to improve the quality of the care for their patients. So if you give them a positive and negative, it's impossible that you could be wrong because either way, you have presented two sides to the issue. The same is also true for the lab procedures. Now, obviously, a disadvantage here is that you will not have the lab procedures in advance of the patient's length of stay. But it would also be worth saying that taking into account the patient's lab history would be beneficial. Perhaps you would look at this over the past 12 months instead of looking over the patient's entire length of stay. So that's what it says. Lower quality responses mention concern about the race variable, just due to regulation or privacy laws, with little or no explanation. Regardless of your response, be sure to provide an adequate explanation. Task 4, 6 points. Write a data summary for your actuarial manager. Summarize your work performed in tasks 1 through 3. Limit your response to 1 page, including any visualizations. Describe the process used to prepare and validate the data. Describe data issues encountered and how you addressed these issues. Provide a data summary, including 1 or 2 visualizations in your data summary. So let's go ahead and consider how we would write this response. You could start by saying, this analysis uses historical records from 10,000 patients who had diabetes who have been readmitted to the hospital. I performed an exploratory study to resolve issues with the data and to help MAAC to improve patient health. The way that this is being tracked is from the number of days which patients spend in the hospital after being admitted. This is shown below. This length of stay ranges from 0 to 15 days, with an average of about 4 days. I found 3 key drivers or leading indicators of length of stay. This is again just reiterating what we found earlier in task 2. These are 1, the patient's age, 2, the number of procedures which they have had in the prior 12 months, and 3, their history of being readmitted. Patients who are older need to spend longer in the hospital. The table below shows that as the patient's age increases, the number of days that they spend in the hospital also increases. To create this table, I simply copied the results from RStudio into Excel. Patients who are younger can recover on their own at home and can be sent out to the hospital sooner, thus freeing up time and resources to care for other patients. Patients who had been readmitted in the prior 30 days had a higher length of stay on average. This was 4.2 days for patients who had never been readmitted, but 4.7 days for patients who had been readmitted in the prior 30 days. These patients have underlying issues or more serious, if these patients have underlying issues or more serious cases of diabetes, and so by considering their history, medical staff can be extra careful when helping these patients to recover. The data that was provided had issues because there were incorrect or blank values. I had to manually fix these using my best judgment. When there were only a few problems with the record, I just omitted it. When I could, I made changes to fix it. 2 questions to keep in mind are 1, are there ethical issues with using a patient's race in this analysis? And 2, can we attain the number of laboratory procedures for patients? And then you could answer these questions. So 2 questions which we considered were here. We concluded that adding in the race variable would be unethical if the data was collected in a discriminatory fashion, but also that there could be advantages, but also that it could help doctors to provide better care. For this analysis, we chose to include it. Regarding the laboratory visits, the lab procedures, we advise against including this because Mac would not have this info in advance. Most candidates performed well on this task. Lower performing responses often included a high-level description of the data source. It did not include any visualizations. So in this case, be sure to include a graph, such as a histogram, or some other type of visualization. The SOA's answer does a great job of breaking up their response using these subheadings: completeness and reasonableness, ethical concerns, and relevance. However, as with every other question on this exam, a wide range of answers is possible. So don't feel like you are constrained to using a specific format like this. The response in this video, which is more of a narrative style, would also be acceptable. Perform principal component analysis. Perform PCA on the selected numeric variables and create a new feature based on the first principal component, using the code provided by your assistant. Describe PCA. Limit your response to half a page. State the advantages and disadvantages of using PCA for this problem. Interpret the output, including the loadings on PC1. Discuss whether other principal components aside from PC1 should be used in the model. Regardless of your response, do not use the other principal components in subsequent tasks. After completing task 5, run the code to split the data into training and test sets. In the following tasks, use the Pearson goodness of fit statistic shown below. So this question is worth 8 points, and it has several parts to it. So let's look at the code to see what they give to us. I see that they have the code here that creates the PCA based on number of procs, number of meds, number of inpatient visits, and number of diagnoses. So first of all, ask yourself, what is principal component analysis? And before you even run the code, you can answer this first part. Describe PCA. Principal component analysis, PCA, is a dimensionality reduction method which attempts to maintain the information in the data while using fewer variables. It breaks down linearly related or correlated variables into principal components, which are linear combinations of the original variables, which are uncorrelated. It allows us to use only a subset of these PCs based on the percentage of variation that which each explains. First, scaling is applied, which subtracts the mean and divides by the standard deviation. This helps to ensure that each variable is given the same amount of weight. Otherwise, variables which have the highest numeric value would have too much influence. Then each variable is rotated or multiplied by a scalar known as the loading. So we can use this info to create a recipe for each PC, which helps us to interpret it. This says describe PCA and limit your response to half a page. So they really expect I believe this is saying limit your response, not just to describe PCA, but no, the way that I would read this is limit your response to half a page refers to just this description, not the total question. So they really expect you to be doing a lot of writing on this task. State the advantages and disadvantages of using PCA for this problem. Well, the advantages for using PCA are that by reducing the number of variables needed for num meds, num procs, interpret the output, including the loadings on PC1. Let's look at the R code. We see here the importance of each component. The first component explains 37% of the variation. of the total variables. The second adds another 27%. The third adds only 21%. And the fourth only adds 14%. So ask yourself this question. If all of the variables num-prox, num-meds, num-IP, num-diegs were independent, then what percentage of the variation would each explain? That is, if there was no correlation between any of the variables. Well, you might be right if you said 25% or 1/4 of the total variation. So the fact that the first component explains 37% means that there is some overlap between the other variables, but not very much. The first two explain 64%, almost 65% of the total variation. But consider if they were uncorrelated, then the first two principal components would explain 50%. So going from 65% up from 50% is not a significant increase. So this suggests that the variables are not closely correlated. And so this principal component analysis is not adding a lot of value. So I'll just copy the results into the document. So the results of the PCA are below. PC explains percentage of the total variation. If these variables were independent, that is, their correlation was 0, then the cumulative proportion would be 25% for each PC. So the fact that the first two PCs only explain 65% of the variation, up from 50% if they were independent, means that this PCA analysis is not able to simplify the data very much. It's not able to simplify the data. There's some simplification, but it may not be worth the effort. So below that, we see the loadings. So what are the loadings? Each principal component is a linear combination of the original variables. A recipe for creating first PC is 0.56 times num-prox plus 0.68 times num-meds plus 0.12 times num-inpatient plus 0.47 times num-diegs. This tells us that the largest group of patients have a large number of diagnoses, medications, inpatient visits, and procedures. We know that this is the largest group because it's the first principal component. So you can think of this as a proxy for health or the patient's health status. So those who are healthy have a low score, and those who are less healthy have a higher score. The second principal component, well, it has negative sign on procedures and negative sign on medications, but high sign on inpatient and diagnosis. It has a positive sign on the number of inpatient visits and diagnoses, but a negative sign on the number of procedures and medications. This group is patients who may have had an injury or other accident which resulted in a trip to the hospital for their diabetes, but which did not require medications or procedures. So we know that this is smaller. We know that this represents fewer patients because it's the second PC and only explains, the second principal component only explains 27%. Third and fourth PC together account for 34%. This represents patients who have procedures, medications, inpatients, but few diagnoses, and patients with, and then finally the fourth principal component, which is the smallest group of patients, have procedures, inpatient visits, and diagnoses, but few medications. Next, discuss whether other principal components aside from PC1 should be used in the model. Regardless of your response, do not use the other principal components in subsequent tasks. So, should you use principal components in a model? In this case, what we said before was that the percentage variance explained for the first principal component is only 38%, which is not very high. So I would not suggest using principal component analysis here because it doesn't add very much value. In other words, it wouldn't improve the model's prediction, and it just makes the result more confusing. But our client was asking us to get insight into the patient's length of stay. So they are less concerned about predictive value and more concerned with understanding the result. So I would just say MAC is more concerned about inference than prediction. And so I recommend using the original variables. The first PC only explains 38% of the total variance, which is not very much. If we were to use PC, I would recommend using at least the first two PCs. But in any case, using PC would make the result more difficult to explain to hospital staff. And then they say, after completing task 5, run the code to split the data into training and test sets. And this says, the following chunk instructs a new feature using the first principal component and attached it to the data frame. Because they say, regardless of your response, do not use the other principal components in subsequent tasks. Okay, so we're only supposed to add PC1, and that's what this does. It also centers and scales the variable. It may be worth explaining what centering and scaling is doing. In general, whenever they give you code to do something, it's a good idea to explain that, just to demonstrate that you know what you're doing. Do I mention scaling? Let's just read over. Yes, I say first scaling is applied. So let's just go ahead and add this to the data. And then if I look at the data, I go to structure, PC1, I can see that it's added as we intended. Next, I'll split the data into training and test sets. I don't need to make any changes here. And then I just confirm the mean number of days in the training, test, and across the whole data set. I want to see that both groups represent the same type of patient so that I won't train my model on one type of patient and then evaluate it on another type of patient. I want to be making an apples to apples comparison when I evaluate my model on the test set. A good idea to say this briefly. Say I split the data into training and test sets. This will help me to evaluate the results, new test data, and to get an accurate idea of how well it will perform in real life. I compared the mean number of days in training test sets, found that it is the same, about 4.4 as in the overall data set. Mac is more concerned about inference than prediction, and so I recommend using the original variables. The first principal component explains 38% of the total variation, which is not very much. If we were to use principal component analysis, I would recommend using at least the first two principal components. Task 5 for principal component analysis was somewhat confusing. In the product statement, it said, describe PCA and limit your response to half a page. However, it's unclear as to whether this was referring to the length of the total response or just to the length of the description of PCA. Now, if you look at the SOA's answer, you'll see that their total answer is more than an entire page. So it seems like this is really just referring to the description of PCA. The solution says that where most people failed was in confusing that PCA is unsupervised learning method. And so it doesn't take into account the target variable at all. So recall that unsupervised learning is when there is no target variable. Supervised learning is when there is a target variable. They also say that many were unable to describe advantages and disadvantages of using PCA for this problem. So it seems like most people are able to provide simple description of what PCA is. The way to get maximum points on the question is to apply it to the specific problem. In this case, you can talk about how PCA for the numeric variables would make it more or less difficult for doctors to interpret the patient's medical history. Task 6. Construct a decision tree. Describe what pruning does and why it might be considered for this business problem. So this question is asking you to explain the theory of what pruning does. If you're not sure on a question like this, you can look in the documentation in R. This is almost like you have a statistics manual in front of you. For instance, you know that the rpart library is where you get the info on the decision tree, right? And so if you look here, you can find a definition. So here is the code, and it's asking you to describe what pruning is doing. So if you go down to the prune function right here, highlight the function and then press F1, and then click on prune or reduce a cost complexity pruning of an rpart object. So right here, this gives you some guidance. So pruning, also known as cost complexity pruning, determines a nested sequence of subtrees of the decision tree by recursively snipping off the least important splits based on the complexity parameter, CP. Now, if you wanted to save time, you could even just copy and paste this and then clean up the formatting. This is appropriate for this business problem of predicting length of stay, because Mac is interested in the insights that they can share with hospital managers, and having a simpler tree will be more actionable for healthcare providers to use. You could go into a little bit more detail about what pruning does. So you could say, like, first I fit a decision tree that is deep or tall with many leaves, and this is then simplified using the pruning algorithm. For each split in the tree, the amount by which the model improves on each split, which is measured by the number of days on the right and left branches of the node, are taken into consideration. And let's run the code to do that. So here is our tree. As you can see, when I just use the default code, it's also removing PC1, and it's just setting these parameter values for CP. And then it fits this very, very deep tree. There are lots of nodes, and it's impossible to interpret. So what do they want you to do? Construct an unpruned regression tree using the code provided. Okay, I've done that. So I'll just quickly copy the result into my Word document. In general, it's good to include more information than you think that's needed, because it doesn't take you that much time, but you can't really lose points for including too much info, but you can definitely lose points if you don't include enough. Okay, this is maybe too much, so I'm not going to include this whole series of if-else statements, but I will take this image. Unpruned tree is below, and so what else do they want you to do? So that's all they say, just say use the code provided. So that means that I don't have to make any changes. Okay, what's the next part? Review the complexity parameter table and plot for this tree. State the optimal complexity parameter and the number of leaves that will result if the tree is pruned using that value. So here's that. So this shows the complexity parameter on the x-axis and the relative error on the y-axis. Now, you might be confused because you don't know what relative error means. In the case of the decision tree, which is a regression tree, I believe that this is the root mean squared error. But in any case, you don't need to be concerned about that. If the question doesn't ask you for it, don't worry about it. Just do what they ask you to do. So I'm reviewing the complexity parameter, and I'm finding the optimal value. So the optimal value is where the relative error is lowest. So I can see the error keeps going down and down and down as the CP parameter gets smaller. And here is the table. So I'm looking at this X error, which has the lowest error. So I can see it starts at 1, which is the worst, the highest value. And I want this to be as low as possible. So it comes down to 0.761, 0.760. So it basically keeps going down, 0.763, 762, 761, 760, 7609, or 7603. That's the lowest point. But this tree has 28 splits, which is a lot, right? So why is this tree so complicated? Well, min bucket is 20. What do they want you to do? And then they say prune the tree. If 8 is not a possible option, select the largest number that is less than 8 that is possible, okay? So here I would just say that the lowest error is going to be this really complex tree, which has 29 splits, but I'm not going to use that because it's too complicated. I use cross-validation to fit trees which have different values of CP, and then choose the one that which has the lowest error, and that's this tree right here. And you can actually see there's a mistake here. It copied too much text, which is common. Sometimes RStudio does this. So you just have to go back and then just recopy the table. There it is. So the lowest error is when you have 28 nodes. So the lowest error is for a tree that is too complicated for this problem because it has 28 nodes for a CP value of 0.00212. And then say prune the tree with the result that will have 8 leaves. So this one will have 8 leaves, so 0.00035. Instead of using this minimum CP value, I chose to use 0.00356 because it has a tree which uses only 8 nodes. Okay, what's the next part? Calculate and compare the Pearson goodness of fit statistic on the test set for both trees, original and pruned. So first of all, what is the Pearson goodness of fit statistic? You might be surprised to see something like this. If you are completely caught off guard and you have no idea, you can try searching in the R documentation. So you can say Pearson. Actually, I don't want to search in this. I want to search here. Global documentation. Pearson goodness of fit. And there's Pearson's chi-squared test for count data. This is in the stats library. So even if I'm not using this function, I can reference the documentation. So chi-squared test performs a chi-squared contingency table test and goodness of fit tests. So if X is a matrix with one row or column, etc., it takes in a contingency table. So this actually is a different function, but what it's doing is it's using the chi-squared test, which is the same idea that we're using here. It's a hypothesis test. It says that the square residuals should have a chi-square distribution, and it gives you a value of a test statistic. And lower that test statistic is, the better, right? Because if these two values are really close together, if your actual predicted value is very close to the real target, then the sum of these squares will be small. Conversely, if your model's bad and these errors are really big, then the square residuals will also be really big, so your model will be worse. That's all that you really need to understand about this statistic. I used the Pearson goodness of fit statistic to evaluate the model. This assumes that the squared error has a chi-squared distribution. I'll say the squared error divided by the predicted value. That's what it's doing. A higher value of this statistic is worse because the residuals are larger. Conversely, a lower value is better because it means that the residuals are smaller. So now I want to look at the chi-squared stat for the unpruned and pruned tree. So here it is on the training set and the test set. You can see on the training it's lower than on the test set, which is always going to be the case. So this is train and test. And then after doing pruning, I just have to set the CP value, remember? Where is that pruned? So tree 2 is right here. And then this says prune the tree by replacing XX with the complexity parameter that will result in 8 leaves. So again, the way that I do this is I just look up here at num split, n split, which is number of leaves, which will result in 8 leaves. Oh, so I don't actually get 8, I actually get 7. They say use the higher value or the lower value. If 8 is not an option, select the largest number less than 8. So that would be 7, right? So I want to see this value. 3, 5, 6, 8. I think that's what I had. 3, 5, 6, 8. Yep. So this will result in 7 nodes. So that's the CP value. And then here's the tree. And I'll also include this. And then the training and test error. So this is before pruning. It's after pruning. CP, the Pearson goodness of fit stat for the training and test sets are below. This is higher, worse on the test sets than on the training sets, as is always the case. After pruning, the test statistic is only slightly worse, from 1.56 to 1.60. This is a good value because considering that the tree has 8 or 7 nodes instead of 28. Prune the tree using complexity parameter. I did that. Calculate and compare the Pearson goodness of fit stat for both trees, original and pruned. Interpret the entire pruned tree, all leaves, in the context of the business problem. I want to justify why I'm using Pearson goodness of fit, right? Why am I not using just R squared instead of, mean absolute error? You might ask why I'm not using a metric such as R squared or root mean squared error or MAE. The reason is because we are modeling a counting value, the number of days spent in the hospital. This gives the data specific characteristics, such as specific properties. For instance, there will be more people with fewer days than the likelihood that a person spends an additional day in the hospital decreases as the number of days increases, right? If I've already spent 5 days in the hospital, I'm more likely to go home than if I've only been there for 1 day. So RMSE or MAE doesn't take this into account, but it just would not take that into consideration. Okay, so the next part was interpret the entire prune tree, all leaves in the context of the business problem. So I just have to read through this tree. So it starts off at the top and it asks a series of yes/no questions. And if it's a yes, it goes left, and if it's a right, it goes a no. To interpret this tree, I start at the top and move down. I move left if the patient meets the given criteria, and I move right if not. At the end, after going through these 1, 2, 3 to 4 questions, there is a predicted number of days. The specifics for this tree are, so I start here, if patients have fewer than 22 medications, and if they have fewer than 14 medications, and if they have fewer than 9 medications, they're predicted to have 2.6 days. The predicted number of days spent in the hospital are 2.6 days for patients with num meds less than 9, 3.5 days for patients with between, I'll just use a greater than or equals to sign. So this has to be between 9 and 14, right? Because it's strictly less than 14, greater than or equal to 9. And then it's 3.7 days for num meds is less than 14. Let's just get rid of this patients. 2.6 days when, 3.5 days when num meds less than 14, and the age is going to be 6, 7, 5, 6, 4, 5, 3, 4, 2, 0. So this means that and age is either 0 to 10, or is there a higher value like 80 to 90? What's the maximum value? We have to go back to our initial data. Age. So 80 to 90 count or other. So is it just other? I could also do data.all. Yeah, so 0 to 10 or 90 to 100. Okay, or 90 to 100. Let's just double check. So 10 to 20. 10 to 20 is not included. 10 to 20. 0 to 10, 10 to 20, 20 to 30, check. 30 to 40, check. 40 to 50, check. 50 to 60, check. 60 to 70, check. So you go down here, num meds. Num meds has to be greater than or equal to 14. Age is not in. So let's say we're going right here. We're going down to this node. This should be 4.9. So we're going to go right here. Then that's 4.9 days. Now I have to make this 3.7 node. This is when num meds is less than 14 and age is either between 20 to 70. There's no 70 to 80. And you could even simplify these intervals further. And I'm not using the right interval notation, I don't think. I can't remember if you use square brackets or round brackets. I'm just going to move on. If I have time, I'll fix that later. So then num meds less than or equal to 17. So that's, you go down here and let me get down. So I'm at this node 3.7. So I have to meet this age criteria, and then num meds has to be less than or equal to 17. So num meds is greater than or equal to 14 and less than 17. So 14, num meds is greater than or equal to num meds, and it's less than 17. Then do the same node greater than or equal to 17. Then it's 4.5 days. Okay, and then 4.9 we said num is less than or equal to 22, greater than or equal to 14. Age is in one of these categories. Yeah. Okay, and then we go over to here. 5.9, so nummeds is greater than 22. Nummeds is less than 28. So for 5.9 days, when nummeds is between 23 and 27. So right here. And then 6.7, when nummeds is, so nummeds has to be greater than 28. And admit type ID is 3 or 4. What is 3 or 4? 3 or 4. So it's elective or not available, And then 8.6 days when it is the other categories, or urgent or emergency. Okay, and that is the entire question. It says, interpret the entire prune tree, all leaves, in the context of the business problem. And just a reminder, this question does not say to use non-technical language. So that means that the audience is the exam grading committee. The audience is not business manager yet. When you get to the executive summary, you'll need to translate it into more businessy language. But for now, it's okay if you use a less than or equal to sign, or you use nummeds, because the exam committee will know what you're talking about. Next, I need to split the data into training and test sets. The code provided will already do that. It will then compare the mean number of days between each of the data sets. You want to see that the overall average is the same as the training and the test set. Include a paragraph in your report that says something like, I split the data into training and test sets. This helps me to evaluate the results on new test data and to get an accurate idea as to how well it will perform in real life. I compared the mean number of days in the training and test sets and found that it is the same, about 4.4, as in the overall data set. Task 6 was an exercise in following very detailed instructions. There were 6 very specific tasks, and even as I was completing this video, it was quite easy to deviate from doing what they were asking to do. The SOA's solution says that this task was made up of several very specific subtasks, and it is important that candidates make sure they are performing the exact task requested. Many candidates seem to ignore detailed requests in the problem statement, myself included, resulting in poorer scores. Some candidates did not explain why pruning was important in the context of the business problem. When choosing the optimal CP parameter, alternative approaches were able to earn full points as long as the approach was justified. Where specifically requested or necessary for facilitating discussion, for example, discussing the CP plot or table, candidates should include our output for their report. Candidates were expected to interpret all leaves of the pruned tree. So as I was just reviewing this, there were actually a few things which I noticed, which I had to change, which the video includes incorrectly. And this is good practice. It's good to review your work. Don't assume that once you complete the task that you have to keep it as it is. If you have some time left at the end of the exam, you can go back and double check your work. So initially, adequate job of explaining what a decision tree is in the pruning process. However, in some cases, I had grammatical errors and the word choices were too complicated. So I had to review and just make simplifications. There was a small typo in the CP value. I included just this number here. And so I had to add this 0 dot. When I was interpreting the decision tree, I noticed that some of the nodes were incorrect. And so I had to go back and review these equalities because I had followed the wrong path when I was interpreting the tree. I also went into more detail than necessary when I started talking about the Pearson goodness of fit statistic. This is a great example of what this solution says when they say that you seem to ignore detailed requests in the problem statement. So consider here, it says calculate and compare the Pearson goodness of fit statistic, the test set for both trees, original and pruned. My report also talks about why the Pearson goodness of fit stat may be useful, but the project statement doesn't ask for justification. It just says calculate and compare. So this was a waste of time, and even if I were not to lose points for including it, it would cost me time that I could have spent on other things. So in summary, for the modeling questions, just be very careful to follow the instructions. Try to take the perspective of the grader. They need to design questions which they have objective answers to. And the only way that they can do that is to give you very specific instructions and then check if you answer those. They say in modeling, there's no right answer. Often multiple models will provide good results. But in the case of exam PA, you need to just follow the instructions as closely as possible. Question 7. 7 points. Construct a generalized linear model. Now, I just want to comment that this question is only 7 points. The prior question was 10 points, but this took us quite a long time to go through each of these bullet points. So when you answer these model questions, just do the bare minimum. Don't do anything fancy. I point this out because the exam solution has this nicely formatted table, which probably took another 2 minutes or so to create. I don't believe that this would be necessary. So the question is, the code provided specifies a Poisson distribution with a log link function. Do not change these assumptions. First part, consider the gamma and binomial distributions. Explain whether these distributions are reasonable alternatives to the Poisson distribution for this data and business problem. So every question for GLMs is going to ask you this question of choose the response distribution. And you don't actually need to look at the test error or anything else besides just thinking of the business problem and looking at the histogram from earlier. So remember that we're modeling the number of patients, which is a count right here, number of days. It's positive and it's right skewed. So you know right off the bat that only positive distributions are going to be allowed, and the binomial will not be allowed because there are more than 2 values. So you could technically use the gamma distribution or the inverse Gaussian distribution. Best choice though is the Poisson distribution because the Poisson models a counting process, which is the number of days, and it takes on discrete values. Now technically the number of days could be a fraction. You could stay in the hospital for 1.5 days, and so continuous values like the Gaussian or the inverse Gaussian would also be viable. Answer this question quickly. So just consider the gamma and binomial. So the target variable, the number of days, is positive and right skewed. It only takes on discrete values in the data, although it is technically possible that a patient could stay for a fraction number of days. So any response distribution which matches these criteria is possible. This means the binomial isn't useful because the data takes more than 2 values. The Poisson is the best choice because this models a counting variable. Gamma is also possible because it is right skewed and positive. In the context of the business problem, it's important that the predictions always be positive because hospitals staff would not be able to make sense of a negative number of days spent in the hospital. The second part, fit a first GLM with all original variables included prior to employing PCA. Then fit a second GLM with the PCA variable created in task 5 included, and without the numeric variables used to produce the PCA variable. It is not necessary to display the output of these GLMs in the report. That's a key part because prior exams have always asked you to do that. So again, read the question closely and save yourself time. Let's go to the GLM question. Here it is. First GLM is not using PC1. It's using Poisson with log link. Do not change. Calculate Pearson goodness of fit, etc., etc. So I really don't have to do anything here. I just have to run the result, and then I'll look at the values of the coefficients. I see most of the p-values are small, meaning the variables are significant. That's good. All that I need though is just these values of the stat. So on the first part, we have train and we have test. And so this is GLM using PCA instead of original variables. And then I need the same stats. So this part will remove numprox, as numip, etc. Let me rephrase that. This is using original variables instead of PCA of the principal component. And then this one is removing the original variables and using the principal component. See, there's the coefficient right there on the principal component. And there's the training and test. And then this is GLM, but let me not say GLM, let me say goodness of fit. The GLM goodness of fit stats are calculated below. So I see here that the GLM using the principal component instead of the original variables has a test error which is slightly higher. The GLM which has the principal component instead of the original variables has a higher, worse test statistic, the principal component. So another disadvantage to using the principal component is that the result will be less interpretable, right? Would also be more difficult to interpret. So this implies that using the first model is better both for performance and for ease of interpretation. Select one of these GLMs to proceed with in the tasks that follow. Justify your recommendation based on the results and the business problem. So in this first model, you can look at like the number of meds, the number of procs, number of inpatients. You can actually see the sign of the coefficient. You can't do that if you have the PC. Task 7. The most successful candidates were able to discuss their distribution choices in light of the data structure and the business problem. So this was justifying the use of the Poisson distribution because the response was a count. Some candidates failed to point out that using principal components may make it more difficult for hospital administrators to understand the drivers of longer hospital stays. This is a good example of putting yourself in the shoes of the target audience, in this case, doctors who need to use your model. Task 8. This is only a 4-point question, so don't spend more than 5 minutes. Perform feature selection with lasso regression. Run a lasso regression using the code provided. The code will need to be modified to reflect your decision in Task 7 regarding the PCA variable. List the features used in the model and calculate the Pearson goodness of fit stat. Compare the resulting model to the GLM in Task 7 and recommend which model is more appropriate for this business problem. So let's just run the code. Lasso matrix train not found. So the comment here says, format data as matrices necessary for GLMNet. Uncomment 2 items that reflect your decision from Task 7. So here's lasso matrix train, and this is model matrix, and it's saying that days is the predictor is the response variable, and it's using all other variables in the data except for PC1. This other one is using the original variables, is removing the original variables, right? So I want the matrix that removes the principal component because that's less interpretable and has worse performance. Then I run this code and I get some GLMNet and then use the cross-validation results to run the final lasso regression model. And there it is. And here's the training and test error. So this is train and test. So let's compare this with the GLM. It said the GLM from task 7. So that's this one. Okay. So we'll need the results here. And recall that we want to use the GLM that has the original variables. We don't want to use the one that has the principal component. That's here. And just to make this a little bit easier to read, I'm going to make this font smaller. I just use Control left bracket. So remember, this is the one with the original variables here. This is GLM from task 7. And then this is the lasso from task 8. So this is 1.55 and the lasso is 1.57, which is worse. However, the GLM is using all of these variables, and if you try to interpret all of these variables, you will spend a lot of time. So this result removes a lot of the variables, and it does that when the coefficient is equal to 0. I recommend that we use this model because the results are to interpret the indicators of a patient's length of stay. So they don't care about model performance. They don't care about this test statistic. It's just a guide for building the model. They really just care about ease of interpretation. So the results from the GLM in task 7 are below. This had a lot of variables, but had a lower, better value of the Pearsonness of fit stat, 1.56, as compared to the lasso, which had a value of 1.57. However, Mac is concerned about ease of interpretation rather than performance. The second model, the lasso, removed a number of variables which will be easier to explain to medical personnel. So I recommend that this model be used. One possible complication is that this will only take into account discrete age values, like it will only ask if the person's age 50 to 60 or 90 to 100. So that might be difficult to interpret. One aspect of this lasso, which may be difficult to explain, is the fact that only certain ages are considered if the patient is between 50, 60, 80, 90, or 90 to 100, rather than having a different coefficient for each age. Again, this was only 4 points. So it's just asking, list the features used in the resulting model. Okay, so the features used in the resulting model are here. So to quickly get rid of the blanks, it might just be fastest to delete things rather than going into Excel. The features used in the lasso are, just delete this, this, this. Actually, it might have been faster if you had created a spreadsheet. Some candidates did not know whether a higher or lower Pearson of goodness of fit statistic was good or bad. This is actually a somewhat common problem. You are using a lot of different statistics, AIC, BIC, RMSE, and so forth. To easily remember if a higher value is better or lower, you can refer to our cheat sheet. For instance, for RMSE, lower is better, but for R squared, a higher value is better. For the Pearson goodness of fit stat, a higher value is also better. Candidates were expected to make a clear model recommendation and justify their choice. Better candidates went beyond comparing the performance and variables of the GLM and lasso models and discussed how both were good or bad for the specific business problem. The key words here are the specific business problem. Either method could be justified and receive full credit. So in our example, we wanted to highlight not just the value of the statistic, like we can say the goodness of fit stats are calculated below. Also consider that the principal component would be more difficult to interpret. And so this implies that the first model is better both for performance and for ease of interpretation. So this goes back to the objective. Is the objective of the report inference, or is the objective prediction? Task 9, 7 points. Discuss the bias-variance trade-off. Define bias and variance and describe the bias-variance trade-off. Explain how lasso regression seeks to address the trade-off. Explain how splitting the data into training and test sets and calculating the metrics such as Pearson goodness of fit statistic on the test set seeks to address the trade-off. So first point, what is bias and what is variance? So you just need to remember the statistical definitions. There's no shortcut for this question. So bias is the difference between the expected value of the model and the expected value of the target. So you can think of this as the difference. This can be thought of as the difference from the center of the target. Variance is the amount by which the predicted value change when the input data changes. This is just the statistical variance of the predicted values. The bias variance trade-off is a very important topic on this exam. In fact, almost everything that you're doing is somehow related to the bias variance trade-off. It says that the mean squared error can be decomposed into the variance of the model plus the bias squared plus some irreducible error. So the mean squared error is going to be never going to be zero. There's always going to be some error. You can make it smaller by reducing the variance, but often that will increase the bias. Conversely, if you decrease the bias, you'll often increase the variance. You can think of this as overfitting or underfitting. If you underfit the model, that is, your model's just like not flexible enough, like let's just say you're taking a simple average, the variance would be very low because you change the data, but the average basically stays the same. The bias would be high because it would just be an average. It would not be very flexible. Contrast that with a really complex model, like a GBM. A GBM would have a high variance because each time the data changes, the model would be very sensitive. It would make changes. However, the bias would be lower because each estimate would be closer to the predicted value. Finally, you have the irreducible error. Think of this as just random noise or variables that are omitted from the data. Traffic interference or coding errors in the way the data was collected. This is something that no model can reduce. So the bias variance trade-off says that the root mean squared error can be decomposed into 3 parts. Part 1, bias squared. Part 2, the variance. Part 3, irreducible. And bias squared models which have high bias tend to have low variance. Models which have high variance often have low bias. Irreducible error, this is random noise which no model can completely remove. What was the question again? Explain how the lasso regression seeks to address the trade-off. So the lasso regression adjusts the model's flexibility. So this graph shows the flexibility on the x-axis versus the interpretability on the y-axis. The flexibility is the amount by which the model changes when the data changes. So on the right here you have like a random forest or a GBM because it can make very nuanced predictions. On the left you have a simple decision tree which makes more rugged or simple predictions. This decision tree is easier to interpret, but it's less flexible. The lasso regression adjusts the model flexibility by adding or removing variables and by making the coefficients of the linear model larger or smaller. So when you adjust the lambda parameter, you move along this line here. So you trade off interpretability for flexibility. When you improve flexibility, you always reduce your error, right? So that's why like a GBM often has better performance than a decision tree. So to put this all into words, I'll say the lasso controls the model bias and variance using the lambda parameter. This imposes a penalty in the log likelihood so that models' coefficients are either removed or made smaller or larger. Models which have fewer variables have lower variance but higher bias because they're less flexible. Conversely, models which have low bias but higher variance have more variables. By looking at many values of lambda and choosing the one which has the lowest error, the GOM can be optimized. The last part, explain how splitting the data into training and test sets and calculating a metric such as the Pearson goodness of fit stat on the test set seeks to address the trade-off. If we didn't split into training and test sets, then we would not be able to measure the bias accurately, right? This is because the model would fit exactly to the data that it was trained on, but if new data was used, then the results would be far worse, right? So by splitting into training and test sets, I can accurately estimate the model error, the Pearson goodness of fit stat in this case, and thus make a decision on the model which will accurately reflect reality. Explain how splitting the data into training test set and calculating metrics such as Pearson goodness of fit seeks to address the trade-off. Many candidates mixed up bias and variance, or were unable to relate variance to overfitting and bias to underfitting. An easy way to remember the difference is in this picture. This shows you the different combinations of having high bias and low variance. Bias is the tendency, so in this case, you have bullet holes in the target, and the goal is obviously to get the bullet holes as close to the bullseye, to the center of the target, as you can. So the bias is the amount by which the bullet holes are centered, and the variance is the grouping. So this target has high variance because the bullet holes are spread out, and it has low bias because the bullet holes are centered. This target, conversely, has low variance and low bias. So this is the best example. This target has high bias because the variables are not centered, but it has low variance. And this target is the worst. It has high variance, and it also has high bias. So how does this relate to overfitting or underfitting? Well, basically, when you have variance that's too high, then you often have bias, which is too low, which is underfitting. And conversely, overfitting is when your variance is too high, and so your model basically changes due to very, very small changes in the input data, but your bias may be. So better candidates explained how model complexity could refer to both the model type and the features included. So again, this goes back to the cheat sheet, which shows that table of the different models and their complexity. So one advantage of using a GLM is that the predictions will change gradually as the input variables change because a GLM uses coefficients for each variable instead of yes or no questions in a decision tree, which results in stepwise predictions that can be difficult to explain. List one advantage and one disadvantage of employing a GLM that does not remove features for this problem versus feature selection using lasso regression. So a lasso has all the benefits of a GLM. It has automatic variable selection for lasso and smaller coefficients for ridge. So it automatically selects variables, and it has better predictive power than a GLM. But in the case of this problem, we don't really care about predictive power, right? In this case, we just want to select a model that gives us better interpretability. It is easier to interpret because it removes variables using the penalty term by setting coefficients equal to 0. So in R, one disadvantage to using the lasso in R is that the log link function is not supported, and so we could only use the identity link. You could also think about the age coefficients that we talked about in the GLM. Remember, all of the age coefficients were included, whereas with the lasso we only had like age 70 to 80 and 90 to 100. Another disadvantage to using GLMs is that the predictor variables need to be uncorrelated for the statistics to be valid. Otherwise, technically you're using more variables than you need. And so advantage to the lasso is that it removes the correlated variables. Finally, the GLM often has lower predictive power than using a lasso. This could be changed. In our case, we just hard-coded the value of lambda. We just used the hyperparameter that was chosen, but you could use cross-validation to select this parameter yourself, and you would most likely get a model that has better predictive power. So there are a lot of possibilities, and don't limit yourself to only what's in the SOA solution. Try to think about your own. Most of all, keep in mind the business context. That's really what the exam committee is looking for. Task 7 asked you to consider the advantages and disadvantages of the final model. As I was answering this question, I did not include the interpretation to the business problem as the SOA solution did. This is really incorrect and would have probably resulted in only earning 2 or 3 points. The solution that you saw in the video was statistically correct. However, an additional step is necessary, and that is to talk about the implications for hospitals. So in the SOA solution, it says, an advantage of a GLM is an increase in the number of medications, et cetera, and then it talks about how this results in having a single coefficient versus having multiple coefficients in the model, right? So if you wanted to expand on this solution, it would be quite easy. Let's start with the first one. One advantage to using a GLM instead of a tree for this problem is that the predictions will change gradually as the inputs change, because a GLM uses coefficients for each variable instead of yes or no questions in a decision tree, which results in stepwise predictions that can be difficult to explain. So hospital staff may be more comfortable seeing their patients' projected length of stay change gradually rather than suddenly. Right? This next one, One disadvantage is that the decision tree handles missing values automatically, which has a problem in our data that I needed to fix manually. The GLM does not handle missing values automatically, and so this will cost additional time if this model was to be used. So Mac should consider the cost of building this model in production when making this decision. And you could say the cost of hiring an actuary's time in building this model. Finally, one advantage to using a lasso is that it is easier to interpret because it removes variables using the penalty term by setting coefficients to 0. This can make the result easier for doctors to understand. Finally, one advantage to using the lasso in R is that the log link function is not supported, and so we could only use the identity link function. So the actuaries who would be hired to train this model just would need to take this into consideration. That's it. So again, the common theme for these questions is always consider the business problem. Task 11. Interpret the model for the client. Run this recommended GLM from task 7 on the full dataset. Copy the model output into your response. Interpret the coefficients for one categorical variable and one numeric variable to describe how these features relate to the target. The interpretation should be written in language that's appropriate for the client. So first of all, we have to find out which model we need to interpret. So let's go back to task 7. So here, remember, we fit two GLMs, one which used the original variables and another which used the principal component. And we found that the one that used the original variables was best. So that's GLM 1. So I need to copy this code down and so that it can be run over the full data set. You might be wondering why we need to do this. And the reason is because when the model is fit, the estimates of the coefficients depend upon the data. And when you have a larger data set, the estimates are more reliable because there's a larger sample size. It's the same concept for any type of statistical estimator. The variance gets smaller as n increases. So I'll just call this GLM all and then move the coefficients into Excel. And then I go to text to columns, delimited, space delimited. And now what I need to do is to apply an inverse to the link function. So recall that this model uses a log link. And so these are our beta coefficients. And to interpret the result, we need to take the exponent of beta. And so what do these results? Recall that these categorical variables are in reference to the base class. What's the base class? That is the most common type of patient that you can find out just by looking at the summary of the data. Summary data.all. And here for the categorical variables, the first category listed is always the base class. So this is females between the ages of 70 to 80 who are Caucasian with admit type 1, which is emergency, who have no metformin, no insulin, no prior readmissions, and so forth. And so let's go ahead and just type that into the document. The most common patient is female between the ages of 70 to 80, Caucasian, has no metformin, insulin, or history of being readmitted. I'm just making this window wider so that it's easier to read. So talk about gender, age, race, admit type 1. What is admit type 1? Admit type 1 was emergency visit. Has been admitted for an emergency, and then these other variables are numeric. So this patient has a predicted length of stay of, so we take e to the 0.79, which turns out to be of 2.2 days. Then for men, we increase this prediction to, actually, let's round these numbers so that they look more precise. We decrease this prediction by multiplying by 0.97. The other pieces of information about the patient produce similar change. Coefficients below, which have a negative sign on the estimate, decrease this prediction, and those with a positive sign increase. And then for the numeric variables, we have numprox, nummeds, numip. And you could interpret any of these. So let's just interpret this one, numprox. So this is the same as multiplying by 1.01. Then we multiply by 1.012 to the nth power, where n is the number of procedures which the patient has had in the past 12 months. There are similar relationships for the number of procedures and number of inpatient visits and number of diagnoses. Task 12. Write an executive summary for the client. This is worth 20 points. It may be a good idea to take a break at this point in order to recover some mental energy and to transfer from thinking in a technical language from thinking to a more non-technical, businessy language. The executive summary's audience is going to be a manager or a sales representative. So it can be confusing to quickly remember all of the steps that you need for an executive summary. To avoid brain fog and writer's block, you may benefit from using an acronym, ROIDS. This stands for Reader, Objective, Issue, Data, and Summary. The reader, in this case, is the audience, the person who will be reading your report. The project statement will tell you that this is merged and acquired clinics and hospitals. The objective is to help executives gain a better understanding. And the issue is the drivers of patient length of stays. So the data is historical inpatient encounters for patients with diabetes. There's also a footnote in the report here, and this says the data are adapted from diabetes, 130 U.S. hospitals for years 1999 to 2008, data set contributed by, etc., for the UCI machine learning repository. So you can also include that it is for U.S. hospitals between 1999 and 2008. For U.S. hospitals between the years of 1999 and 2008. You can also include the variables. So each encounter includes the length of hospital stay measured in days, as well as each of the variables. This is just a summary of the data dictionary. So I would say this is their admission type, age, gender, to summarize, I would say, as well as their gender, age, race, weight. They were admitted for an emergency, elective, or non-elective reason. If there were changes to their metformin or insulin, so to say any changes to their metformin or insulin prescriptions, their history of being readmitted past 12 months, as well as their medical history in the last 12 months, such as the number of readmissions in the past 30 days, number of procedures, medications, inpatient visits, and diagnoses. And then finally, this summary, which is just going to be the body of your report. So this will include things like your selected model, conclusions, data visualizations, and then future next steps, and finally a conclusion. You don't need to include this actual table in your report or even take the pains of typing all of this out, but just think in your mind, ROIDS. This will help you when you write. For instance, you can immediately say, our client, merged and acquired clinics and hospitals, has hired us to help their hospital executives to gain a better understanding of the factors that drive inpatient length of stay. We used predictive analytics to identify the reasons why some patients are sent back home quickly and other patients need to spend several days in the hospital. So we used data we used historical inpatient encounters for patients with diabetes between the years 1990 and 1988, et cetera. You can also include a limitation here, because a limitation of this analysis is that it is based only on patients who had diabetes. Well, another way to say this is just any conclusions of this report are limited to the population of this data set and would change if applied to a different population. And then you can go right into the results. So the way that I like to do this is to go up to View and then Split, and then just scroll up to the interpretation part of my report. And I'll go ahead and delete this table now that we've written that initial opening paragraph. So let's just go back up to the interpretation. So recall from our GLM, we had already looked at the variables from task 7. This was our final model. So I want to go back up to task 7 here, and be sure to use the GLM that was from the complete data set. And so here's our table of coefficients, and we want to add a new column called interpretation, and we start, so we say start with a prediction of 2.2 days, and then you want to make a little sentence that says if the patient is male, multiply by, and then you want ampersand 0.97, and I actually want to round this, so I type in round and then the number of decimal places. I will even use 2 decimal places. And then I'll just need to change the name. So if the patient is male, if the age is between 10 and 20, if the age is between 20 and 30, and this will never be automatic. There will always be customization here, so don't spend too much time trying to make a perfect formula. And then 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90, and then finally 90 to 100. And then if patient's race is African American, do this for the race variables. And we're almost done. Now we just have admit type 2. Admit type 2, let's look at the data dictionary. This is urgent. If the patient's readmission was urgent, or 3, which was elective. And then we just have these metformin. If the patient's metformin was steady, or if it was up or down, if their patient's insulin was steady or down, insulin. It's helpful if you can spell insulin correctly. Steady, down, or up. And then if they were so let's see. Okay, we're almost there. We just have another 6 variables to go. So if readmitted indicates whether patient had been readmitted after an inpatient stay in the 12 months preceding the encounter. So this is either less. Okay, so if the patient had not been readmitted in the last 30 days, if the patient had been readmitted in the past 30 days. So for each number of procedures that the patient has had, you multiply by 1.01. So for each procedure that the patient has had, multiply by, you need to say equals, quotes, and then by the factor. So this is procedure, medication that the patient had, inpatient visit, and diagnosis. And now you just need the final column here. You don't actually need the first 2 columns for the estimate and the variable name. And then paste that into the document. Some introduction. So we can provide you with a table that can be used by your healthcare staff in order to predict how long a patient will spend in the hospital. This uses a simple spreadsheet, and based on the patient's characteristic, adjusts their length of stay. So you could use this either to predict which patients are on track or on course to have a long stay and then to intervene, or you could just interpret these results directly. So you can see below that different factors either increase or decrease length of stay. We start with a prediction of 2.2 days. This represents female patients between the ages of, I'll go back up to the model interpretation question. Let's just say this represents the most common patient. Then, if they are male, multiply by 2.22. If they are between the ages of 10 and 20, decrease the estimate by multiplying by 0.97. If they are between ages 20 and 30, decrease again by multiplying by 0.91. Each of these variables is interpreted in the same way. Now, in this question, try not to just repeat everything that you've done prior. Try to be original or to make some observations or even recommendations. Now, all that's remaining is to summarize your result. Just go through each of your tasks and write a few paragraphs that explain what you did. So I'll just go back up to task 1 here, all the way up to task 1, and then say what we did. Edited the data for missing and invalid data. How can you write that in non-technical language? To ensure that the quality of this analysis is the best that it can be, we performed integrity checks of the data prior to beginning the analysis. This involved correcting errors in the data and removing values which were incomplete. So I noticed there were a few patients who had missing records for their gender. These were removed. The patient's race was not included for 226 cases. So because this represents too many to ignore, and so because this is too many to ignore, we included them as a separate group. We were supplied with the patient's weight, but did not use this because it was not included for the majority of patient records. This is a serious problem with the data which MAC should examine. Then we conducted task 2, which is explore the data. We used visual and statistical methods to look for patterns. We found that most patients who are readmitted spend about 4 days in the hospital. We looked at the other patient information to see if there was a clear difference in the type of patient who had a long stay in the hospital as compared to a patient who had a short stay. I would include this table here for age. Actually, let's go back to that question where we summarized the data for the manager here. Yeah, and I want to be careful that I don't include redundant info. So I already talked about age, so maybe I could just talk about a different variable, like this readmitted patient. I would include this table here. I wouldn't include this box plot because box plots can be awkward to explain to a non-technical audience. It's easier to just use a table like this. So this is average days in hospital. You don't need the median. And this is the number of patients. And then this readmitted is patients who have not been readmitted in the past 30 days. Patients who have been readmitted greater than 30 days ago. Patients who have recently been readmitted within the last 30 days. And maybe I could cut this down even more. No readmission history, recent readmission, history of readmission, and then round these numbers down and clean up the formatting. So we found that here that patients who had a recent readmission had a longer hospital stay than those who hadn't, who had a recent hospital stay within the last 30 days, had a longer stay on average than other patients. There were 1,102 patients in this group, which is a significant number. So it may be worth considering, if these patients have something different about them, such as other chronic illness, and including this info within the analysis. Perhaps your medical team would have more insight here that could help. Let's think about another variable, and let's try to include a graph. We included a table. People also like to look at graphs. So I could actually go back to my report, and I could even create another graph. Of course, this is dependent on how much time you have in the exam. If you're really running out of time, then I would probably spend the time writing rather than creating a graph. Let's consider one of the numeric variables, like the number of procs or the number of procedures. So let's create a scatter plot like they did in the official solution. They create a scatter plot. So let's take data.all and ggplot aesthetic, and we want two variables. We want days, and then we want let's say numprocs. Actually, did we look at the correlation? Yeah, we did. We looked at the correlation here. We saw nummeds had the highest correlation, right? So let's go and look at nummeds, and then we'll say geom point. And before doing this, I have to load the dplyr library, and I might have to load the ggplot2 library. I could also just load the tidyverse library and save myself that time. Okay, so here you could see the number of days on the x-axis and the number of medications on the y-axis. And again, if you wanted to see like the number of procs, you could do that too. Actually, that's not very helpful. What are the other variables? NumIP. That doesn't seem to have a clear pattern. Or you could look at numdiags. I think nummeds is the most interesting. And so you could even add like another level to this. Like you could look at the number of procedures and the admission type. If you really wanted to, you could say color equals admission type, and maybe you would see a pattern there. But at this point, it would really be burning the clock. So this is something that's really a way of adding extra points to your exam once you have the executive summary written. But maybe there's a pattern here. Like you can definitely see that as the number of days increases, that it looks like the number of medications tends to increase. Like these patients here who have 60 medications in the last 30 days, all of them have more than 5 days in the hospital. So I would just maybe adjust the size of this point. Size is equal to 1.5, and then alpha is equal to 0.2. Color equals blue, and you could do as much as you want. You could even say GG plus theme minimal. That's the one that I like to use. And then you could add the title number of days versus number of medications. And then you want to add the X lab of days, and then the Y lab, like so. An alternative is you could even use Microsoft Excel to create graphs. To do that, just open up the data set, and then say I would save this as a new version, as an Excel workbook. Be careful not to overwrite the data. And then maybe just create a pivot table or a pivot chart, and I want to look at like days versus, actually I can't create an XY plot using a pivot chart, so I want days on the x-axis, and I want nummeds on the y-axis. Days in hospital, number of medications, and past 30 days, and then insert scatter plot. Yeah, so there's absolutely no reason why you can't use Microsoft Excel to create graphs too. Actually, that's probably easier to format than ggplot2 graph, and you can also edit the titles directly. So I'd actually go ahead and use that in the report, and then add the titles, add the axis titles. So this is number of days. In task 3, we were asked to investigate 2 data issues. These were for including race in the model and for including the number of lab procedures. It may be helpful at this point to look back at the project statement to get an idea as to what questions they wanted answers to. So here in task 3, they said, identify 2 data issues. They say, so think about it like this. The project statement is asking a question, and your report is answering that question. So this question was, what are the potential ethical concerns of using race in the model? And then you can answer that question here in the report. So you could say there are ethical concerns with using the patient's race in the model. It may be the case that this info helps healthcare providers to prevent discrimination from occurring, or it could be that this info creates a bias in the model, which gives people different levels of treatment of quality of care depending on their race, which would be discriminatory. So this has legal risks because of potential lawsuits. And then the other concern was whether the number of laboratory visits should be included. And remember, we said that it wasn't. It should not be included because it would be leaking the signal into the length of stay of the hospital. So we concluded that the other info in the data was complete and informative for the patient's length of stay. We recommend against using the number of laboratory visits, which my assistant mentioned, because this would not be possible to collect from patients in advance of knowing their hospital stay. And then we'll just move on to task 4. Write a data summary for your actuarial manager. It's important here not to repeat what you said before, because they specifically say not to do that. So the project statement said, write a data summary for your manager and then summarize your response. So you could just provide commentary on what you did. So we sent our actuarial manager a summary of all of the data steps. You can review this information with them to follow up on any of the above steps. And here you could just say, we considered this summary contains our process of cleaning the data and would be useful for repeating this analysis. And then you could perhaps talk about the leading indicators. There are also 3 findings here related to what factors predict a patient's length of stay. These were 1, the patient's age, their age, 2, the number of procedures that they've had in the prior 12 months, and 3, their history of being readmitted. Task 5, perform principal component analysis. So again, here I want to look at the project statement to ask, what is it that I'm doing? What question am I answering? They say perform PCI and selected numeric variables. And this doesn't really tell you why you're doing it. It just tells you to run principal component analysis. So what really is the purpose? So the reason was because we found correlations between the info in the patient's health history. There was overlapping information in their number of medications, procedures, past readmissions, and diagnoses. And so we investigated a method of liquefying this down into a single score. This would give you the option of using fewer input columns. Now, it actually wouldn't use fewer input columns because you would still need the original columns. So this would have the advantage of, this would give you the option of using a single score that would take into account the patient's history, instead using the separate columns in the data for these values. The advantage would be that the set of rules would be simpler, but more difficult for your hospital staff to understand. For this reason, we recommend not using this approach. You could also interpret the PCA. So you can interpret the PCA by looking at the loading factors. So you could just interpret the first principal component and see that this represents patients who have a lot of procedures, medications, inpatient visits, and diagnosis. You may already be aware that there's a group of patients who have a high number of procedures, medications, inpatient visits, and diagnoses. You can also look at the correlations. Remember, I don't think that we included the correlations here. Correlations are easier to explain than something like principal component analysis. So the correlation was highest for the number of medications and the number of days. Many of these patients, one way to find which factors are related to the length of the hospital stay is by looking at the correlations. When two things are correlated, it means that one increases as the other increases, and vice versa for decreasing. When the number of medications which a patient had increased, their length of stay did as well. It's important to remember that correlation does not imply causation. It could be, for instance, that patients who have more medications have other health issues which are causing their increased length of stay. So we recommend using the results from our predictive model, which includes these other factors and adjusts for them. And this is a standalone sentence, so perhaps I would link this sentence up to this sentence above. So we found correlations between the info in the patient's health history and their length of stay. I'm going to delete this and then move this paragraph up. So I'll sort of introduce correlation analysis. Let me just say you can simplify the info that you collect on a patient's history down into a single number. This would give you the option of using a single score that will take into account their the patient's history instead of using separate columns with the data values. The advantage would be that the set of rules would be simpler to use, implement, but more difficult for your hospital staff to understand. And then I would say the recipe for this is, and now I just want to take the loading factors of this first principal component. So this would be 0.56 times PC1 times number of patients, let's put this in parentheses, times number of procedures plus 0.67 times number of medications plus 0.12 times number of inpatient visits plus 0.47 number of diagnoses. Okay, moving on to task 6, which is construct a decision tree. And we don't need to include results from models that we don't use because this project is just looking at inference. And so because we don't end up using the decision tree, I would not even talk about the results. You could just say that we investigated several alternate model approaches so that the results which we are presenting to you are as reliable as possible. We created experiments with each of these methods and chose the one which has the best match of the actual patient readmission patterns. In other words, we are only showing you the best results from our modeling. We also looked at decision trees, penalized regression, decision trees, and penalized regression. And we don't need to spend our time interpreting this decision tree because we already have a set of rules based on the GLM. It's also important to demonstrate the credibility of your result. And this is almost always the same. It's using a training and test split. So say you can be confident that these results will work in real life because they have already been tested using a scientific approach known as training, testing, validation. This used 70% of the patients as a training set, and the remaining 30% were held out as a blind test set. We evaluated each of the models based on this test set, and ended up selecting a generalized linear model, GLM, because it had the best result. You can interpret, we interpreted this model into the table of rules, which we included earlier. So now we're down to task 7, where we selected the GLM and we selected the features. We could also talk about the bias variance trade-off. This is perhaps getting more technical than is needed, though. If you do talk about this, keep it at a very high level. So just as a general discussion, so MAAC may be interested in building a model which has better predictive power. We considered this. You would need to consider a trade-off between interpretability, which is how explainable the results would be to your hospital staff, versus the predictive power. We chose a model which is easy to interpret. However, also you could consider more powerful models as well. Our report looked at this on the topic on the bias variance trade-off. I would not use the words bias variance trade-off because that is technical language. Our report considered not only the statistical power of the model, but also the ease of interpretation, and contains guidance for constructing more complex models. And this is a long paragraph. I could simplify this down. Mac may be interested in building a model which has better predictive power. You would need to look at the trade-off between interpretability, which is how explainable the results would be to your hospital staff, versus the predictive power. We chose a model which is easy to interpret. However, you could consider more powerful models as well. And then consider the final model. We talk about the advantages and disadvantages and so forth. So you could say there may be other advantages to using a different model. No, not there may be. There are other advantages and disadvantages to using a different model. For example, some of the data cleaning work that we needed to do could be automated if using a tree-based model. This would be filling in missing values, detecting nonlinearities, and detecting interaction effects. And then task 11 was interpret the model, which we have already done. So now I would just consider next steps and a brief conclusion for this report. So your next steps should consider several factors. You may wish to follow up with your hospital staff regarding these issues. How may these, and then just try to think about different factors that would change if you were to conduct this analysis again. For instance, how may these results change for non-diabetes patients? Or what additional data could be collected on these patients? Would medical prescription, would the type of prescription, for example, be useful to know so that doctors could see if certain medications are causing longer hospital stays? Or perhaps the age of the data, more recent data, be collected. This study was based from 1999 to 2008, but medical records have changed in the last 12 years, and so this study may be out of date. And then finally, I would say, in conclusion, we identified the factors which determine how long a patient will spend in the hospital after being readmitted. We present these results to you so that you can take proactive action in caring for your patients in the best way possible. Once you have about 10 minutes remaining in your exam and you've already submitted the first version, it will be a good idea to go back and to make sure that everything is polished. Notice that in the description it says, the executive summary will be graded based on the quality of the presentation. Note that a component of the grading for the first 11 tasks will also relate to the quality of the exposition. So things like typographical errors, spelling mistakes, or formatting inconsistencies can cost you a few points on the test. So once you finish writing, go back and then just do a quick read through. Fortunately, Microsoft Word will give you any highlights for spelling mistakes. So each time you see a blue underline word, simply right click and then choose the selected highlight. So here I'm missing a comma, so I'll just go ahead and add the comma. Actually, in this case, I'm just going to remove the so, and I would just read aloud to myself in my head. There are some cases where I could use better language, and it's important that I use consistent tense. If I use past tense in part of the report, for instance, here I say I grouped the variables together, which is the past tense. Then I shouldn't use the present tense here where I say doesn't. So I should change this to did not matter. It did not matter why this variable was missing. Here I say I converted all of the factors' base levels to those which had the most observations. So you could actually include that explicitly. So if you look at summary data.all, you could just copy this result and then just decrease the font here. So use control left bracket and then say you can see these values below as they are the first value listed. This is gender equals female, age is equal to 70 to 80, and so forth. And then I would move this down to the end of the report after I've discussed these other variables. So in summary, some of the most common mistakes that I was making were using informal instead of formal language, using wouldn't or can't instead of would not or cannot. I also often began using so at the beginning of sentences, which is not very professional. So besides the obvious spelling mistakes, just be careful to use the appropriate language for the task at hand.